Hydraulic systems. The S-64 Echo uses 7 different hydraulic systems to perform various functions. Each system incorporates a pump, reservoir, filters, except for the rotor brake system, manifold, and pressure relief valve. In addition to various other necessary components, the systems are first stage, second stage, utility, makeup, hoist, rotor brake, auxiliary. Flight control hydraulic system. Due to the size and weight of the main and tail rotor heads, and to prevent feedback, it is necessary to make the control inputs through a system of hydraulics. There is no direct flyable mechanical linkage to the main or tail rotor heads. The control linkages proceed to the valves on the tandem servos of both heads, and the flight controls move only the adjustable pilot valves. Each individual servo then hydraulically moves the head according to the control inputs it receives. The main head has 3 tandem servos, left lateral, right lateral, fore and aft, and the tail rotor has only 1 tandem servo. The 3 main rotor tandem servos are mounted between the main rotor swatch plate and the upper bearing support of the main gearbox. The main rotor tandem servos consist of 2 sets of chambers mounted in tandem on the single power piston in the housing. The housing contains a pressure and return port, a bypass valve, a pilot valve for each set of chambers. Each servo is capable of operating independently of either set of chambers. In normal operation, pressure is supplied to both sets of chambers by the first and second stages of the servo hydraulic systems. One servo unit operates whenever the pilot valve controlling hydraulic pressure from both stages, or in case of failure, a single stage of the systems are mechanically moved by the cockpit flight controls. Both valves operate simultaneously. If one stage of the system is shut off, the hydraulic oil from that stage is bypassed within the servos. The servos will continue to operate on the pressure supplied from the other stage without an increase in control forces. The servos operate separately, tilt the swatch plate in direction corresponding to the pilot's inputs. The first stage supplies 3000 psi hydraulic pressure to the main rotor servo cylinders. The second stage system supplies 2000 psi hydraulic pressure to the second stage of the main rotor servos and through pressure reducer, 1500 psi to the tail rotor second stage. The utility system provides pressure to the first stage of the tail rotor servo at 1500 psi. There are 3 gauges in the center of the instrument panel for monitoring the first and second stage hydraulics, as well as the utility hydraulic system. The first stage servo hydraulic system. The first stage servo hydraulics, also called first stage hydraulics, is a high pressure system that only provides the hydraulic pressure to the first stage of the 3 main rotor servos. The pump is driven by an accessory gearbox and produces 3000 psi, the pressure whenever the rotor is churning. The first stage reservoir is mounted on the rear left hand corner of the hydraulic sled. Capacity is about 0.45 gallons. There is a sight gauge and a fill cap on the reservoir. System utilizes a 15-micron return filter without bypass and a pop-out button indicating pressure differential at the filter. A manifold controls the system. The manifold consists of a housing containing a 2-position 3-way solenoid operating control valve, a 10 or 3-micron filter depending on installation, a relief valve, a pressure switch, and a pressure snubber. The 3-way control valve directs hydraulic fluid to the system or trapped under pressure in the system to the reservoir. The filter protects the system from contamination. If the filter becomes plugged from contamination, a red pressure differential indicator pops. The relief valve in the first stage manifold is set at 3500 psi. The snubber dampens the pressure surges to the pressure indicating system and the pressure switch. Low pressure in the system, below 2000 plus or minus 75 psi, will activate the first stage servo caution light. Second stage servo hydraulic system. The second stage servo hydraulics, also called the second stage hydraulics, is a high pressure system that provides pressure to the second stage of the 3 main rotor tandem servos, as well as the second stage of the tail rotor tandem servo. The pump is driven by the number 1 engine accessory drive gearbox and produces 2000 psi pressure whenever engine is running. The reservoir filter and manifold are identical to those on the first stage. In addition, the second stage incorporates a pressure reducer to reduce the pressure from 1500 for the tail rotor servo. Low pressure in the system below 1500 plus or minus 50 psi will activate the second stage servo caution light. In the event of a number 1 engine fire, a second stage hydraulic system emergency shutoff has been installed to prevent the flammable hydraulic fluid from draining from the second stage reservoir and further feeding the fire. The switch is located on the overhead quadrant near the N1 controls for easy access. The shutoff valve is located inside the fuselage at station 229. First and second stage interlock. The first and second stage systems are electrically interlocked, which prevents both systems from being turned off at the same time. The flight control servo switches on the collective grip allow the pilots to turn off one system at a time. If one system fails, the interlock prevents the pilot from turning off the remaining good system. If one system is off when the other system fails, the good system will automatically be switched to on. The interlock is designed such that if one pilot has selected one system off with his collective switch, the other pilot cannot select the other system off with his collective switch and have both hydraulic systems off. The interlock requires a minimum pressure of 2000 plus or minus 75 psi in the first stage before the second stage shutoff valve can be turned off. The second stage must have 1500 plus or minus 75 psi before the first stage shutoff valve can be turned off. The interlock pressure switch is mounted in the tandem with the servo press caution light switch and attached to the first and second stage hydraulic manifolds. Note, there is no interlock for the tail rotor servo. Utility hydraulic system. The utility pump is located on the main transmission accessory gearbox and is powered by the main rotor when turning, or the APP. It supplies 1500 psi pressure to operate the following subsystems: APHIS servo, including the pedal dampener and stick trim system, boost for the wheel brake system, first stage, tail rotor, load leveler, release system. Not installed. The reservoir is located on the left forward corner of the hydraulic sled and is identical to the first and second stage reservoirs. The 10 micron size filter has no bypass capability. A red button will pop out if 100 psi pressure difference occurs from one side of the filter to the other. A manifold containing a 2-position 3-way control valve, a 10 micron filter relief valve, a pressure switch, and a pressure snubber is installed on the hydraulic sled. The solenoid-controlled 3-way control valve directs hydraulic fluid to the APHIS system and returns fluid trapped under pressure in the system to the reservoir. The filter protects the system from contamination. If the filter becomes plugged from contamination, a red pressure differential indicator pops. The relief valve in the manifolds is set at 1750 psi, and excess hydraulic fluid is routed back to the reservoir. The snubber dampens pressure surges to the pressure indicating system and pressure switch. A pressure reducer is installed in the hydraulic lines above the APHIS servo unit in the control closet. Utility hydraulic system pressure of 1500 psi is reduced to 60 psi for the APHIS servo unit stick, beeper, trim valves on the lateral and fore and aft servo banks. The pilot has no direct control of the utility system. There is a pressure gauge on the control panel directly under the first and second stage pressure gauges to indicate system pressure. A utility system failure will be indicated by illumination of caution panel segment lights marked first stage tail rotor and APHIS servo press. Subsystems. APHIS servo. C flight controls. Wheel brake boost. Each pilot's pedals have toe brakes attached to the top of the pedals. The toe brakes create pressure manually and are assisted by a power boost cylinder which utilizes utility hydraulic pressure. The brake pressure goes to the disc brakes located on each landing gear wheel. The toe brakes have the ability to activate the disc brakes without the utility hydraulic system. A shuttle valve is located between the pilot and co-pilot brakes to prevent both pilots from applying brakes at the same time. The brake system has a parking brake valve which traps hydraulic pressure in the brake system when activated by pulling up the parking brake handle. A parking brake advisory light is actuated by the parking brake handle. Note: the illumination of the parking brake advisory light does not guarantee that the parking brakes are set. The light is activated by pulling up the parking brake handle, regardless of the pressure in the system. Operation: initial pressure on the toe brake pedals supplies manually developed hydraulic pressure to the wheel brakes. Contamination of the pressure on the pedals causes the utility hydraulic system pressure to supplement the manually developed pressure through the power boost cylinders. The utility hydraulic system supplies 1500 psi pressure to operate the hydraulic power boost portion of the brake system. Developed pressure in the brake system is limited to a max of 800 psi. To set the parking brake, hold the brake pedals down, moving the parking brake handle up slowly. To release the parking brake, hold the brake pedals down and slowly move the handle down to the off position. First stage tail rotor pressure. The utility system provides 1500 psi pressure for the first stage side of the tail rotor tandem servo. The system is controlled by a first stage hydraulic switch. This switch controls the tail rotor shutoff valve located on the lower half corner of the right side of the hydraulic sled. The pressure switch for the first stage tail rotor servo caution light is located below the shutoff valve. Caution: there is no interlock between the utility and second stage systems. If the utility system fails, do not shut off the second stage hydraulics, as all control to the tail rotor will be lost. Makeup hydraulic system. The makeup hydraulic system provides pressure to the following: jack and kneel at 1500 psi, hoist brake 400 psi, shock charge 400 psi, emergency upper hook 400 psi, anti-cavitation 100 psi, hoist pump case cooling. The makeup pump is located on the accessory section of the main gearbox and operates at 1500 psi and up to 6.5 gallons per minute. It is powered by the APP or when the rotor is churning. Fluid is supplied to the pump from a 3.05 gallon reservoir located on the hydraulic sled. The reservoir is shared with the hoist system. The outlet of the reservoir incorporates a temperature switch and temperature bulb. The switch activates the hoist oil hot caution light when the oil temperature is above 120 degrees Celsius. The temp bulb operates the hoist oil temperature gauge on the right side of the instrument panel. A pressure switch located on the back of the hydraulic sled activates the hoist oil press caution light when the makeup system pressure falls below 100 plus or minus 50 psi. This is to prevent damage to the hoist pump from inadequate anti-cavitation flow from the makeup pump. Caution: if the hoist oil press caution light illuminates, do not attempt engine start or use the hoist as damage will occur to the hoist pump. Landing gear and jack and kneel system. The system allows the raising and lowering of the aircraft via main struts. Each strut can be raised or lowered independently and has a travel of 0 to 8 inches. The system is not available on the E-model aircraft using F-model landing gear. System components: jacking chamber and piston. Located inside each strut, the chamber holds hydraulic fluid when the gear is jacked. The piston extends or retracts to adjust the length of the strut. Jack valves, located on the hydraulic sled, open and close to allow individual or simultaneous jacking of the struts. Kneel valves, open or close to allow individual or simultaneous kneeling of the struts. Valves are located on the sled. Restrictors, prevent surges during jacking and control the kneeling rate. Check valves, prevent accidental kneeling and isolate the right and left system. Jack and kneel switches, located on the center console master panel. The switches are 3 positions marked kneel, off, and jack. The switches are spring-loaded to off from the kneel position. Limit switches, turns off the landing gear kneeled caution light when the struts are fully extended. It also breaks the circuit to the jack valve when fully jacked. Energy absorption fuses, protects the landing gear from hard landings in excess of 11.9 feet per second at 3.5 Gs. The fuses will shear and allow meter fluid to transfer from the jacking chamber to the landing gear stiff leg, and the gear will go to the kneeled position. Caution: make sure the gear is fully jacked before landing to ensure the full protection of the fuses. Also, do not fly or taxi aircraft with landing gear kneeled, and do not attempt to jack the gear once the fuses have blown. The fluid will be pumped out into the stiff leg through the fuses. Hoist hydraulic system. The hoist pump is a variable flow, servo-controlled, pressure demand, piston-type pump. When there is no demand, the pump produces no pressure. Pressure is up to 3,500 psi at a flow rate of 3.5 to 17 gallons per minute. The pump is supercharged by the makeup pump ensure adequate fluid flow and to prevent cavitation and damage to the pump. Hoist pump operates the cargo hoist and engine starters. Cargo hoist, located in the hoist well immediately below the main transmission. The hoist is a large powered reel with 120 feet of cable wound around it. The first 100 feet of cable is usable, with the last 20 feet being painted yellow. The cable should not be unwound past the point where the yellow starts to show to prevent possibility of the cable slipping off the drum. A single full swiveling open throat hook with keeper is attached to the cable. Additionally, the system incorporates the following components: hoist control switch, located on the right side of the center console. The switch is rotary type marked off, co-pilot, pilot, and aft pilot. It is used to select who will have control of the hoist through the hoist switch. In addition, the switch controls who has control of the pawn circle when installed. Hoist switches, located on the underside of each collective stick. Each switch is spring-loaded off with a momentary up or down position by pushing forward or aft on the switch. Hoist override switch, located on the overhead control panel, marked hoist cable override, off, on. The switch is spring-loaded off. Switch allows the pilot to bypass the hoist up limit switch and reel the cable up to a snug position in the hoist bell mouth. Hoist up limit switch stops the hoist up operation automatically with the hook about 6 to 8 inches from full up. Hoist down limit switch stops the hoist travel at approximately 100 feet of down travel. Hoist up safety switch, located on the side of the hoist. It stops the hoist operation if the hoist is activated after the hook has been snugged against the bell mouth, or in the case of a hoist runaway. Prevents structural damage to the aircraft. Hoist decoupler, located between the torque reaction arm of the hoist and the forward bulkhead of the hoist well. The decoupler lessens force feedback from the hoist to the airframe and acts as a load cell from the hoist load indicator. The hoist load indicator shows how much cable tension is on the winch. The gauge is marked winch load and reads in pounds times 1,000. It is graduated in 1,000-pound increments from 0 to 36,000 pounds. Hoist brake system. The hoist drum incorporates a spring-loaded on brake to stop the hoist drum from unwinding due to pressure loss. The brake is released by makeup hydraulic pressure when the hoist control up and down switch is activated. The makeup pressure is reduced to about 400 psi when going to the brake. Engine start system. The hoist pump provides up to 3,500 psi to the starter motors for engine start. Hoist pump output is limited to about 15 plus or minus 0.5 gallons per minute by a flow regulator in the attic. Prevents starter motor overspeed. And caution advisory light on the advisory panel in the cockpit illuminates when the engine starters are activated. 2 start pressure switches located on the engine deck activate at 2,250 psi to activate the holding circuit for the system. When the engine is self-sustaining, pressure in the system drops below 2,000 plus or minus 75 psi, approximately 26 plus or minus 4% and 1, and the holding circuit is deactivated. Rotor brake system. A hand-operated pump provides 30 to 1,000 psi pressure to a disc-type rotor brake mounted on the left input coil of the main transmission. The purpose of the rotor brake is to stop the main rotor during start and shutdown, and to keep the rotor from turning when the aircraft is parked. The system is self-contained and includes the following components. High pressure switch. The rotor brake on advisory light is controlled by the high pressure switch at 845 psi. Low pressure switch activates at 10 plus or minus 1 psi and serves to notify the pilot there is pressure in the rotor brake system. The switch activates caution panel segment light marked rotor brake press. Relief valve opens at 1000 psi to protect the system from high pressure. Three-way dump valve. Used to dump the pressure from the system, it is activated by the rotor brake switch on the center console being placed in the rail position to release the brake. Rotor brake uses two self-adjusting pucks that engage the brake disc when the pressure reaches about 20 psi. Rotor brake handle and pump, located over the left pilot seat. The handle is pumped to set the brake until both the rotor brake press and the rotor brake on lights illuminate. Auxiliary hydraulic system, AUXPAC. The auxiliary hydraulic system provides 3000 psi at 30 gallons per minute to operate fire tank pond snorkel, water cannon, and the logging grapples. The AUXPAC is attached to the right-hand gear stiff leg. It receives pressure from a pump attached to and driven by the number 2 input of the main transmission. Because the reservoir is mounted below the pump, the reservoir must be pressurized to ensure a constant supply of fluid to the pump. An electric air compressor supplies pressure to the reservoir. An accumulator mounted under the stiff leg absorbs back pressure shocks to protect system components. AUXPAC components. Reservoir. The reservoir is pressurized. It has an internal filter, a quantity indicator, a temperature switch, and a set gauge for servicing. Reservoir holds approximately 5.5 US gallons. A check valve is located in the pump supply line to keep fluid from draining back to the reservoir when the system is not pressurized. Relief valve. A main system relief valve is located in the pump pressure line going to a four-way valve. It is set to crack at 4,200 psi. Four-way valve, located on the bottom of the AUXPAC, it ports fluid pressure to operate the snorkel, water cannon, and to open and close the logging grapple. Electric air compressor. The air pump is energized with 28-volt DC when the battery is turned on and will continue to pump until the hydraulic reservoir is pressurized to 25 psi. At 25 psi, pressure switches turns off the pump. 15 psi, pressure switch turns on the pump. When the pressure drops below 10 psi, the low pressure switch turns on a warning light. A relief valve is set at 40 psi to protect the system from overpressurization. The compressor unit is powered anytime the battery is on and is protected by a circuit breaker marked aux hide, located in the number 1 DC primary bus panel. Indicators. The indication panel contains a temperature indicator showing the fluid temperature as it leaves the reservoir. Two amber press to test type lights are below the temperature indicator. The one on the left, labeled low hydraulic level, illuminates when the fluid in the reservoir drops below an acceptable level. The one on the right, labeled pump and op, illuminates when the output pressure of the air pump drops below 10 psi. Note: sled designs and component locations may differ from aircraft to aircraft.